The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Thanks, Peter. We went on a journey here in Michigan, and I think I'm kind of the setup man for the experts that come after me. I'm a practitioner rather than the researcher that develops the logical reasons why things happen. But the talk talks about improvements. Why do we need to improve? When we do what we've always done, we should expect the same result. And we've been doing this for 100 years. It's in 1906 we did some paving in Michigan, and it's always worked, right? Why would we want to change anything? Well, something changed in early 2000. We saw some things that we didn't like, some things we wondered about. Our test that we took, every slump test was in spec, every air test was in spec, and man, we nailed strength. We were 50% higher on strength on every single sublot. So we knew we had good concrete, right? What more do we really need? 2 or 3 years into the life of a pavement, we were starting to see these shadows develop. And we were going, what's going on here? What's happening? When I was traveling this spring, about a week ago, I was down in Orlando, and I noticed Orlando Airport, same kind of shadows going on, okay? Now, obviously, in Orlando, they don't have the same problems we have in Michigan because there's something they don't have down in Orlando that we have here. It's a 4-letter word called snow. But notice the shadowing on this joint versus the shadowing on this part of the joint. Why is it different? Well, a couple of reasons, but the main thing is this was probably a slip form pavement, and that was done by hand. So that just gives you a little tickler to think about as we go forward here. So what's changed? You know, everybody talks about the EPA restrictions on the cement. New admixtures. We came up with these things called synthetic admixtures, so we can blame them for all of the problems in the world. A big one, the snow and ice policy changed. The departments and the local agencies went to a zero tolerance for snow and for ice and snow, so they started pre-treating, and these guys came out of the woodwork with some really neat, cool stuff. Some brines out of the salt, out of the oil wells, and they would treat pavements on Friday on regular time because it was going to snow on Sunday on overtime. So they would pre-treat the pavements. So we were really trying new policies here. Cement fineness. Something's going on with the cement. We're getting 28-day strengths in less than 24 hours at times, okay? So we're really accelerating this process. We find in our reports unhydrated cement particles surrounding the aggregates. We are trying double gap graded mixes, right? Throw in some cyclopean aggregate so we don't have to use as much paste. ASR, that was a big buzzword. So we've realized that the ASR did exist. And then we had drainable bases, that we were making drainable base pavements. But were we really creating bathtubs to soak our concrete in, or did we really drain our pavements? So the common enemy that we have here in Michigan is water. It's our greatest asset, but our worst enemy. Water stays in the joints for long periods of time. And when we get to 85% saturation rate of the pavement slab itself, Jason Weiss, formerly of Purdue, now of Oregon State, has showed us that one freeze-thaw cycle gives you instant damage once you reach that saturation point. So here's some pavements 35 years old, and all of a sudden, over the course of a couple of years, it goes south. Here's a pavement in Dearborn, not far from here, where we actually do have ASR. ASR shows up in about 12 to 14 years. You know, this one was 35 years old, but we got some newer pavements that after 5 or 6 years look like that. So I ask you, what is missing? Take a look at this photograph, you can see the aggregates there. it's kind of sticking out of the pavement like a sore thumb. So what's missing is the paste. We've lost the glue. So the path to today, how do we get here, and where are we, and what have we done? There was a photographer that worked for MDOT nicknamed Rocky. And in 1997, Rocky did a report, and he identified calcium hydroxide depletion as one of the things that's happening. So near the joints, when you make concrete, the part of the byproduct of the cement hydration process is a byproduct called chalk, CH, calcium hydroxide. That is water soluble. So where you have water, that salt, that chalk can dissolve and flush out of the system, and that's why we see the shadowing. In '98, they also started going to reduce cement paste by using this bigger aggregate, but what they did is they tried to go with a big ag. That created a problem where we had to highly vibrate our concretes, created a problem with our air systems. Larry Sutter up at Michigan Tech did a study for South Dakota, started in about 2002 to 2008, looking into the de-icer issues. And a neat thing happened to us in the industry is one of our contractors had to do a job here at Selfridge Air Force Base on the north side of Detroit. They had to use a Corps of Engineers spec, and the Corps of Engineers had gone into these well-graded mixes earlier than most of the DOTs did. So they had some experiences, and they found out this is a pretty neat way to make concrete. So the path to today started in 2002, 2004, we started experimenting with the state on Jim Shillstone's well-graded mixes idea. Jim's idea had finally come to fruition here. In 2005, our contractors purchased an air void analyzer, a $50,000 piece of equipment. But what they found out was that batching practices matter. It's not a great QA tool, but you could see how making minor changes in how you batch the concrete could make a significant change in the air void system. How we operate make a difference. In 2005, we actually moved it into the ready mix world. So we actually had some ready mix guys using these well-graded mixes, and those mixes are doing very well. We also said, enough is enough, we've heard enough. We went and hired the National Concrete Center. Jim Grove was the principal investigator for us, and they did some investigating with 3 of the local counties here that donated cores and experimental materials. They came back to us with a problem, said, Houston, you have a problem. Now, when I inherited the job of the director at the Michigan Concrete Association, about the first day I came on the job, we got this report back. And I said, you know what, I can't go to my customers and give them a report that says you have a problem. So what we did was we produced a recommended specification for the local agencies to use that would solve these problems we thought going forward. We identified ASR as something we wanted to fight. We wanted to make sure we had a quality air system, and we had some construction practices that had to be cleaned up. But when you write a specification is thou shalt not. It doesn't give you the ability to tell people why you say that. So what we wrote is a third document, a guide that says this is the background. So I called all of these experts around the country that knew what ASR and durability. So I talked to Tom Van Dam, I talked to Mike Thomas, I talked to Doug Hooten, I talked to Peter Taylor, I talked to a lot of these guys, and guess what? Out of 10 PhDs, I got 10 different answers on the right way to go, right? 15 answers, yeah. So what we put together was is a layman's explanation of 10 or 15 or 20 PhD helps, and that's what we ran with, okay? The contractors now started choosing a durable mix by default, and because they ended up with better control. So as an option, many of our contractors started using what we call a very durable, well-graded mix with SCMs in it, that we check the air system before and after the paver. So we by just possible economics, we started doing this stuff. We got into stockpile training because moisture in the aggregate is a key ingredient to the construction practice. How the loader operators handle the materials and maintain the gradation was a key part of what we found out. It's all teamwork. In 2012, MDOT updated their spec book and they pulled out the section that said October 15th, fly ash and SCMs go away. Jason Weiss was talking with me at one of the meetings. He says, I just wish I could find a state that required it year-round. And I said, it's already done. We've been doing it. What the contractors have to do nowadays is use a boiler in the fall at their portable batch plants so they can keep their mix temperature around 70 degrees. At 70-degree mix temperature, the SCMs don't slow the mix down that badly. If you try to batch with SCMs in this climate, in 50-degree weather, 40-degree weather, you're going to have problems. But we have learned how to deal with this. So where are we headed? The legislature got involved in the funding of highways in Michigan last year. And now they are the world's experts at designing and constructing pavements. So that could be coming to a state near you too. But they put a requirement in that MDOT now start doing some demonstration projects with a 30-year and a 50-year design life. Their original most of the standard DOTs designed for about 20 years. So they required this. And what we're taking advantage of now, we know we can make good concrete, but can we build a good base to put concrete on? So it's a whole complete system. So we're working more on the bases than we are on the concrete because we think we're pretty much there on our concrete. New test procedures, right? How long have we been measuring slump? How long have we been measuring total air content? And how long have we been measuring strength? And is there anybody in this room that thinks those three properties are the only thing we need to know? So we're getting into some new tests. SAM, Tyler Lay's super intermeter. That is going to be required on many of the projects in Michigan starting this year. The DOT has purchased 7 of those meters in the last month, and the contractors are going to be using it. We're going to use it as a quality control tool for the first year or two until we develop enough data to set a specification limit. But we are hoping that this super air meter will help us identify not only the amount of air, but the quality of that air system. Resistivity. We start looking at the joint shadowing. That's all part of permeability. And we're seeing some really good correlations in some of these states on the resistivity meter. Now I did hear that Florida didn't get as good a correlation as Louisiana did. But on further investigation, what I'm finding out is Louisiana used one aggregate source. If you go to Florida, there's about a dozen quarries around the state that they get aggregate from. And what we're seeing, we found in Michigan on some testing we've done as an association, is a huge difference between 2 different aggregate sources on the number that we get out of the resistivity. But we've got to be measuring something more than just total air content and strength. We're going to use Cure as a pay item this year. We're going to measure the timeliness of the application. We're going to measure the quantity of the cure applied, and we're going to have a measure of the uniformity. You know, curing as a miscellaneous incidental item, nobody goes back and watches the cure guy. As long as it gets painted white before the end of the day, everybody's happy. But now we're going to be putting a lot more attention and detail to it as well. Joint cutting and cleaning and curing practices. When I got in the paving business 40 years ago, we would saw a joint and we'd leave it there, the slurry. And you could get out of your pickup truck a week later and slip and fall on that slurry because it was pretty wet and damp. What do we do today? Because of all the environmental dust regulations, we saw a joint that night, we flush it down and clean all that slurry off the slab immediately. We no longer have that curing of the joint saw cut any longer. Maybe that's part of our problem. And now Larry Sutter's been working on this, and so is Jason Weiss. sealers. Do we need to start sealing waterproofing? I mean, you buy a new pair of work boots, you put mink oil on it to keep that leather from getting soaked up with water and debris. Are we at the point where we start needing to treat those interior faces of our joints before we apply the sealant? That's some of the places that we're still ready to head to. The rest of these speakers are going to be telling us a lot more detail about what we were seeing here. But I will tell you, this is a piece of pavement that was built 14 years ago now. We don't see any joint staining. That same contractor built a project out of the same batch plant site with the same mix design, with one exception, that they used straight cement and not an SCM. The same admix, the same aggregate, the same sand, same plant, the same operation. This summer we are going to replace about 6 miles of that freeway pavement that was made with straight cement. ASR was a problem we tried to solve, and maybe the salt attack, it was even a bigger thing that we didn't even know about, but the solution was kind of the same. SCMs, supplemental cements, is there, and the other big thing that we've done is we've really worked on the quality of the air system and not just the total air content. So that's where we are today. That's kind of sets the stage for the stuff that Peter and Tom and Rick and Mark are going to be talking about coming forward. So,
any questions for Dan?
Yeah. What MDOT has been trying is some 100% siloxane sealers. 100% product. 40% doesn't seem to make the big difference, but 100% sealer does make. We've also tried some of the soybean oils or some of the bean oils that are out there. Yep.
You're going to point out the difference between slip form and just regular form, or what difference would that make?
I think I teased you a little bit on the shadowing. The shadowing is much more prevalent in the handwork. In the handwork area, typically you'll use almost the same mix, but you'll put a little more water in it. It makes it a little more wet, okay? So that makes that concrete a little lower water cement ratio, a little less dense. And now the water has a better chance of getting into a handwork pour than it does a slip form pour. The nice thing about Orlando is it doesn't matter. They can have the shadowing all the way. You know, they could have 12-foot wide shadowing and it wouldn't hurt them because they don't go through the freeze-thaw cycles like we do. They don't have to put the salts on their runways like we do on our roads here. So, but the same process is happening in Orlando with the rain and the water and the moisture that we have here in Michigan. Yep.
So when sand is required, some components, what changes are you expecting using sand?
I think what we are probably, right now our current practice is we sample the concrete for acceptance in front of the paver and test the total air content. We go behind the paver on a periodic basis and pull a sample out of the same load of concrete. If we see a large delta greater than 1.5%, it's a shutdown and a redo. In most cases, we're seeing about a 0.5% loss of air through a paving process. Because we are checking for quality of our air system, I don't think we're going to see a major change because of the SAM. But I think we will get a much more accurate depiction of the air quality through the SAM system than we are with just our, we're kind of doing a belts and suspenders temporary system. So we're hoping that the SAM does make a good thing. Just one thing on the SAM meter, it's about a $3,000 investment. It's not a $50,000 investment like the air void analyzer is. So it's something that I can see coming into practice. Yep.
Curious, do you use TNS still?
What's that?
Do you utilize TNS still?
No, we don't. This is all plain concrete. Yep. Yep. Current practices with resistivity, we are in the process of trying to just set up the correlation. We have one meter that we bought as the association that we've been using, And one of our guys that does a lot of the quality control testing has run probably 30 or 40,000 repetition tests with it. So we have a lot of data that we're gathering, but we're probably going to institute some of the, there's an AASHTO provisional that's out there right now. We will, once we gather more data here in Michigan, we believe we probably have to have an aggregate correction factor or something like that that applies to the aggregate we use. But we're looking for, we really think that it should replace, make it a lot easier than the chloride penetration test. So.
Great. Well, you've done a big hand.